In the world of computer networks, circuit switching is a fundamental concept. It is a method of communication that establishes a dedicated path between two or more devices. This dedicated path, like a reserved lane on a highway, ensures uninterrupted and reliable data transmission. Circuit switching has been the backbone of traditional telephony systems for decades. Circuit switching is like making a phone call. When you dial a number, you are requesting a dedicated connection to the recipient's phone. Once the connection is established, you can talk without interruption until you hang up. Similarly, in network communication, circuit switching creates a dedicated channel for data transmission, ensuring its integrity and order. This method is different from another popular method called packet switching. In packet switching, data is divided into small packets and sent over the network independently. These packets may take different routes and arrive at the destination in a different order. Circuit switching, on the other hand, maintains a constant connection, ensuring that data arrives in the same order it was sent. The concept of circuit switching is crucial for understanding the evolution of communication networks. It laid the foundation for reliable voice communication and continues to be relevant in specific applications today. In the next section, we will delve deeper into the workings of circuit switching. Circuit switching operates in three distinct phases: circuit establishment, data transmission, and circuit teardown. Let's break down each phase. First, circuit establishment. This phase is like dialing a phone number. The sending device requests a connection to the receiving device through a series of switches. The network establishes a dedicated path between the two devices, like connecting a series of pipes to create a direct flow. Next, data transmission. Once the circuit is established, data flows continuously and uninterrupted through the dedicated path. This is similar to the conversation you have on a phone call after the connection is made. The dedicated path ensures that data arrives in the same order it was sent with minimal delay. And finally, circuit teardown. After the data transmission is complete, the circuit is disconnected. This is like hanging up the phone call. The resources allocated for the connection are released and become available for other communications. This three-step process ensures reliable and ordered data transmission in circuit switching. While it might seem straightforward, the underlying mechanisms involve complex signaling and switching protocols that ensure efficient resource utilization and reliable communication. Circuit switching exhibits several key characteristics that distinguish it from other communication methods. First, dedicated path. The most defining characteristic is the establishment of a dedicated path between the communicating devices. This path remains exclusive for the duration of the communication, ensuring uninterrupted data flow. Think of it like having a private lane on a highway, reserved just for your vehicle. Second, guaranteed bandwidth. With a dedicated path, circuit switching guarantees a certain amount of bandwidth for the transmission. This means the connection enjoys a consistent data transfer rate, which is crucial for applications like voice and video calls that require real-time communication. Imagine having a dedicated water pipe with a fixed diameter. The water flow rate remains constant. Third, low latency. Because data travels through a dedicated path without interference, circuit switching offers low latency. Latency, or delay, is the time it takes for data to travel from the source to the destination. This characteristic is vital for real-time applications where even small delays can disrupt the flow of information. And finally, resource utilization. While circuit switching offers dedicated resources and guaranteed performance, it can lead to inefficient resource utilization if the connection is idle. Just like an empty reserved lane on a highway, an inactive circuit still holds onto resources that could be used for other communications. These characteristics make circuit switching suitable for applications requiring high reliability, guaranteed bandwidth, and low latency, such as traditional voice calls. However, its rigidity and potential for inefficient resource utilization make it less suitable for applications with bursty data transmission patterns like web browsing. Circuit switching has been the cornerstone of traditional telephony systems. When you make a phone call, the network establishes a circuit between your phone and the recipient's phone, allowing for real-time voice communication. The dedicated connection ensures that your voice reaches the other person without significant delays or interruptions. However, with the rise of the internet and data-intensive applications, packet switching has emerged as the dominant communication method. Unlike circuit switching, packet switching breaks data into small packets and sends them independently across the network. These packets can take different routes and arrive at the destination out of order, but they are reassembled at the receiving end. Here's a table highlighting the key differences between circuit switching and packet switching, feature circuit switching, packet switching. Path dedicated, shared bandwidth. Guaranteed variable latency. Low variable, potentially higher resource utilization can be inefficient if the circuit is idle. Generally more efficient data format, continuous stream discrete packets. Packet switching offers greater flexibility and efficiency for handling the bursty nature of internet traffic. While circuit switching is well suited for applications requiring constant bandwidth and low latency, packet switching excels in scenarios with fluctuating bandwidth demands and tolerance for some latency. In conclusion, circuit switching, while a legacy technology, remains relevant in specific applications like telephony, where dedicated resources and low latency are crucial. However, packet switching has overtaken as the dominant communication method for the internet and data networks due to its flexibility and efficiency in handling diverse traffic patterns.